All right. What do you were they able to help you?
No, unfortunately, because I'm doing this stupid linear time.
Uh,
I could just start naming all of them, and then you can tell me which one is right. Well, I could just say that the answer to every single other question we ever asked was K and N.
K nearest neighbors. I'm glad you got that answer, and that was a really good answer to give. I think it might have been a guess though, and so we should at least convince ourselves that this is a reasonable thing.
Well, let's see. How does K and N work? You find the things that are closest to you,
Hmm.
and you let them vote. And if it's a number, or even if it's not, you end up basically taking an average.
So if we know where the anchor points are, which the K, defined points are, and we want to know what happens at some other point, all we have to do is say, okay, well, it's the average of the K nearest neighbors. In other words, it's 1 over K. I think I'm overloading K.
Okay.
That we have a whole bunch of points at where the value is defined, but to figure out for some other point, some point that we want to extrapolate to or interpolate to, we take the K nearest neighbors, like K is 3 here, and we give whatever the values are at those points a weight of a third. And so that's a convex combination of anchor points.
Right.
K and N is totally an averager.
And even the extensions to it, where you take averages based upon distance and such, it's still going to be a convex combination.
Yes, that's exactly right, because they are in fact exactly averaging values together.
Mm-hmm.
And in fact, lots of kernel versions of this have that same property. So yeah, K and N and friends.
It really is the answer to everything.
So, all right, so there are natural function approximators that have this form. There's other new things that we could define, and all we're constrained by, if we're an averager, is that the value at a point whose value we don't know needs to be representable as a fixed convex combination of some values that we do know. Okay?
Okay.
It sounds like a reasonable thing. It sounds like a fairly general thing, and not a particularly weird and scary thing, but it's just what you can do with it is just brilliant.
Show me the brilliance.